Hi there, welcome back to the channel and welcome to the start of a new restoration project on a tube radio. And this one is big. This is a Graetz Melodia 519 and it is big. It's 60 something centimeters wide and I have to pull it forward to rotate it on the bench, and the camera is all the way back here, so yeah, it's big. And I like the color. I really like this light oaky color. There are a few dings and defects on this guy, which is fine. Doesn't worry us too much. But I like this one. I really like the look of it. And when I bought this, I noticed there wasn't that much wrong with it. Not really. I mean, some of the damage or some of the defects are just cosmetic. You know, the lacquer is chipping away, which is fine. I'm going to have to remove that anyway. This is going to be tip-tinned as well. And let's have a closer look and see what we're looking at here. There's something different about this radio that I'll show you in a second because I haven't seen it myself. Before we carry on, I just want to thank the sponsors of this video, PCBWay. You'll find them at pcbway.com. This is the company I go to for all my PCB prototyping. And besides the incredible prices and very quick turnaround times, I get all the options I may wish for when designing or choosing the characteristics of my PC boards. Now that's what I normally use, but they also offer an incredible range of other services, like advanced PCBs, rigid flex PCBs. They do project assembly, provide SMD stencils, and also do CNC and 3D printing, which is something that I'm slowly getting into. 3D printing is incredible here as well. You just upload the CAD file in any of these formats, give them the characteristics that you want, and they'll give you a price. So whatever it is you need, go to the products and capabilities page and you'll see an incredible menu of what they can do for you. So visit PCBWay, I'm sure you'll find something for your needs. First thing we notice is that the grill cloth is in impeccable condition. And this is rather a different type of grill cloth as well. There seems to be like two layers to it. There's like let me show you this. This has got two layers. There's this outer one, which is actually plastic. It's supposed to look like a weave, but it's not. It's actually a plastic. And then there's fabric at the back. Interesting. Gives it sort of a 3D look. I like it. The important thing is it's in very, very good shape. None of this weave is broken. That would have been terrible. And we've got the usual bands. We've got off, TA. If you push these two together, you get TB. This is gramophone and tape. FA is ferrite antenna. If you want the ferrite antenna to operate instead of the external antenna. Long wave, medium wave, short wave, and FM. And unfortunately, FM has been used a lot because the knob is broken. This is always a problem. I have had mixed results trying to fix one of these. We'll see how this one comes out. Let's see what else this thing has got. There's a magic eye. It's one of the expensive ones. This is volume. And I'm not sure if the bottom is separate. No, it's not. Just for volume. And then we've got our tone control here. You can see the window showing us the amount of bass we're putting in here. These guys will be, what is this? Oh, I see. This is the control of the type of speaker system. Alson L, which means, I think, external loudspeaker, external speaker. These aren't clicking. Okay. External, Mag-O, I don't know what that means, Mag-Og. And Raumklang, that's room sound. I think this is the feature they've got, which we'll see when we open up the back, I hope. It actually gives us a hint here. It says Raumklang, what is that? Schallkompressor. Okay, there's some sort of sound compression system in here, which I haven't worked on before, and I'm interested to see how that operates. Let's have a look at the rest. And on this side, we've got our treble, again with a little window showing us the amount of treble we've chosen. There are 3 preset tonal controls: orchestra, solo, and speech. That's pretty normal for these radios. Good. And then there's the tuning. And again, I don't know if the back is separate. No, it's not. So this will use a clutch system. I can see the actual, yeah, that one's working on shortwave. What happens when you push FM? Oh, okay. It's sort of trying to go along, but it's only going along to the left, not to the right. So cords might have a problem, or the clutch mechanism needs some seeing to. Now I'm going to look for something which I missed in the last radio, which was KW looper. In the last radio I restored, I almost missed it all the way to the end. There's our long wave. There's our medium wave, 550 to 1.6 something. That's fine. Then we've got short wave from 6 megahertz all the way to 18 megahertz. Now you see that's the problem. When you've got shortwave that goes all the way across here and you're trying to tune in, fine tune to a little station somewhere, it's very, very difficult to tune it properly unless they had a band spread, and I don't see any band spread. What a pity. Okay, well, you can't get it all every time. On the side you've got those speaker grills, but they're pretty small. They're actually very, very small. And nothing else on here except some pretty faded lacquer. And the back, well, what can I tell you? It's just very big. We've got the usual, the antenna sockets there. This will be gramophone, tape deck, voltage selector. You can see through the little window there, and an external speaker. Nothing else. I'm just going to remove these two screws and we'll see what the inside looks like. Ooh, yes, okay. I see what that Raumklang is all about. This does not look too original. It's been put on here like that with some of the wires showing. That's okay, a little bit of adventure. Never killed, well actually it has killed a lot of people, but never mind. Now this thing has got these weird things here, which are like pipes. That's all I can describe it as. This speaker system is quite complex. I've got to shift this and show you. This wouldn't be stereo at all, no. Unless it's stereo, no it's not, it's mono. But it's got two massive speakers over there. There's a little one in the middle there, which would be some sort of mid-range. And then there's this thing over here. And this thing is another part of the speaker network, because I can see it connected with capacitors, which means this will be for high frequencies. And it'll feed the sound to these pipes over here, which I believe, this is strange, man. This is really strange. Sound will come out these little holes here and also out the side. It's like they're piping hot air. I don't know how well this works. It's one of the reasons I got it, because I was curious, and we'll find out together. I have no idea at all. Oh, and while we're here, we can look at the inside. Well, you don't see much, do you? The usual cobwebs, we'll see that properly when we get it out of the cabinet. Quite a bit more visible here. We've got the transformer over here, the voltage selector, 220, 240, good. Okay, it's got a selenium rectifier on the side here. The dial cords seem to be in place. It's probably the clutch mechanism that wasn't slipping properly. There's the FM block with the ECC 85. This will be an ECH 81, I think. Yep, I'll just leave it there. The AM tuning condenser's over here. Usually you see it on the left of the radio. This one is over here. IF cans. What is this tube? Is it an EF89? Yep, EF89. I've got some of those. I always like to work on radios that I have spare tubes for. Makes a lot easier job of it. You know, this might sound crazy, but I can't see. Oh, there it is. I couldn't see the output tube. The output tube, I believe, is an EL84, is at the back there behind this plate, which holds up the ferrite antenna. Filter caps bubbling nicely. Whoa, this one's really popped. And this guy here will be, what is this? EABC80. Good, I've got one of those as well. Quite a few, actually. So it doesn't look too scary. Everything looks pretty normal. That's the magic eye over there. That one is one of the tough ones to get. The EM34. Actually, come to think of it, I think I might have a spare one there somewhere. Okay, output transformer at the bottom. This is all sort of the wrong way around. Ha! Amazing. This is all sort of backwards. There's a socket over here, which is probably, usually this is the power section. This is going to the front there. I'm getting a little bit afraid of maybe having problems getting this thing out of the case, because that's what I'm going to do next. I'm going to get this thing out of the case, and I certainly hope that this thing allows me to take whatever I need out of the case to test it. This might just be for those buttons on the front, which should be quite easy to interconnect when I want to test the radio. I want the majority of the radio to come out in one piece, because that just makes it a lot easier to work on it. And you put this in the fixture and flip it around and all that stuff, and you can do the whole thing. And now if you've got things like this hanging around that you can't connect easily, it means that when I'm testing the radio, I've got to put the parts together again. Right, I'm going to get this thing disconnected, take it out. What I can see that I'm going to need to desolder are speaker cable. The speaker wire doesn't look original. I wonder. There's another speaker wire over here to the top. So it'll be the speakers I'll be desoldering or clipping away, and then I'll solder them back later and get this chassis out of the cabinet. Now that I've got this thing on the fixture, I actually want to see if it works at all. I'm going to be powering it up with the dim bulb limiter at the back there. There's one light bulb only, so there's a 40-watt light bulb in series that will really seriously restrict the current flowing through this. It's dirty, it's all that stuff, but I don't see anything dramatically broken. So let's give it a shot. I'm going to put it on medium wave, put the tone all the way up. I put the volume all the way up. I've got the speaker connected to the two main speaker outlets on there. I've checked that there's continuity, and let's hit it and watch this light bulb. Oh, it's a bit bright. Oh, but the dial lamps come on. That bulb was bright, but it's dimming. 40 watts, so there's not that much current. Oh, I can hear hum already. Listen to this. It's not volume dependent. Let me give it another light bulb. It's drawing 160 milliamps, which is not bad, but I don't hear anything. Let's give it a moment. Actually, while it's heating up, I'm going to try the external input, the gramophone input. I'll just touch the... Ah, brilliant. Can you hear that? So our audio amp is working. That means the EL84 and the EABC80 is doing something. Let's try medium wave again. I can hear absolutely nothing except hum. There is hum. I can hear the hum on the speaker. Don't expect anything on FM because it needs practically full voltage for that to work, and I don't want to do that. It's seeing 190 volts at the moment. It's drawing 180 milliamps. Okay, that's all I want to know. I'm not going to push this any further. But this has actually told us quite a bit. It's told us that the transformer's working, the power transformer's working. It's told us that it's getting the heater supply, and in fact I saw the EL84's heater light up there. It's telling us that there is some B+, so we wouldn't get any hum at all. It's also telling us that our filter caps are completely kaput, which I expected. I saw the gunk coming out the top there, so that's no big surprise. And it's telling us that the audio path seems to be okay, which means the output transformer seems to be okay as well. That sort of cuts down the possible issues. But I'm getting absolutely nothing on here. The only thing I got is when I selected phono and I touched the back, it was increasing the buzz. It's making noise, which means that the audio section seems to be working, as seems to be the case with the switching that lets the audio section go through. But other than that, we know nothing, and this light bulb is burnt out. And so what I'm going to do is I'm not going to risk this any further with power on here. I know that the filter caps need a full looking into, because they are indeed allowing the hum through. We can hear that, not very loud, but we can hear that. So I'm going to work on the power supply first, and then I'll focus on the audio section, get this thing working in that order. Power supply, audio, radio, and then we've got a lot of cabinet work to do. Okay, that makes things a little bit clearer, but there is hope. There's always hope, but there's hope that parts of this are actually in working order as it is. Okay, let's have a quick look on the underside, because I didn't show you that. This underside actually looks very, very clean in that there's a lot of space. Things are pretty neatly laid out here. There are a lot of paper caps. All these paper caps will be replaced, but there's nothing unduly out of reach here, which is good because it always makes it easier. Let me just check something here. I see a spring system here. I don't know what that is. You see that over here? This thing has got to do with the tuning. And I think, yes, it is. It's got to do with the FM tuning. This does work on a clutch system. You can see that. It pulls it back. It's pulling that in there. This is a different type of clutch system. I've never seen this before. You see, when you hit FM, if you look at that, this pulls this down, okay? So this spring is just to pull this down. When you got AM, any of the AM, it stays at the top and it's grabbing a particular part of the dial cord, and then if you push it down, it pulls that down and it changes what that catches. So we'll have to look on the underside there to see exactly how that clutch works. Okay, so that is just to switch from FM. This is obviously connected to the FM switch over here. Okay, no big mystery there. So there's a paper cap over there. These are those aero caps. They are usually notoriously bad. Quite a lot more down here. There's 1, 2, 3, 4, 5, 6. Oh, there's a lot of them. The power switch is really just a toggle switch that gets pulled and pushed. It's actually accessible, but it is working because we know we've got power switching on and off. These tone controls are the open type, prone to getting a lot of dirt on there, but also very easy to clean. Here's the other one. Volume control back there. That part there is pretty busy. That's the output section, the output transformers on the outside. So we've got all these paper caps over here, which will have tonal tasks. This is involved with the tone control, tone shaping and all that. There's also that socket over there, so that will also be selecting some of these tonal paths to give you different sounds, like orchestra, solo, speech, and so on. I'll look at that in the schematic when I get to it. This here is the cathode bypass capacitor, electrolytic. There'll be another electrolytic somewhere here. There it is. That one down there will probably be the FM discriminator cap. Other than that, on the underside, we've got no more electrolytics, I don't think. No. The switching section over here, all the switches are working, it seems, but they'll need to be cleaned. But it's all in this whole assembly. There are cobwebs, and sometimes you can't tell which is a cobweb and which is an actual wire from these coils. So this has to be cleaned very, very carefully. This is all very easy to get to. Very easy to get to. And I'm actually hoping that these resistors are the type that hold their value very, very well. Sometimes they stay to within like 1% for life, and sometimes they just go terribly wrong and you've got to replace them all. But I think these are the good ones. Anyway, I'll be checking all that. First thing I want to do is sort out the issue with the hum. The power supply filter cap comes out through there, which is a little strange because the selenium rectifier is over here. There's the power transformer, selenium rectifier. I'll be able to replace that with one of my little boards. I think that's exactly the spacing that those boards are designed for. And then this seems to go all the way across to the other side to meet the capacitor. I might be able to do something about that. I think maybe the first filter cap could actually be placed here, because I definitely want to eliminate that cap completely at the other end. I might have to restuff it. I'll just see how we get along. For those who've complimented me on working on a very clean workbench in the past, this is not one of those occasions. Bit of a mess. I've got to clean this up because I've actually gone pretty far with this guy. Not that it's visible from the top, except for perhaps a section that's already sort of been cleaned. And the reason it's been cleaned is that I started with the power supply, and first part of the power supply was obviously the transformer. Checked the connections, checked the continuities, it's all fine. We know the transformer itself probably would be working because it powered up. And the first thing I replaced was the selenium rectifier. It was very accessible. And this particular rectifier, which is this one here, it's an AG. I've worked with it before. I've come across it before. The Siemens ones seem to hold out a little bit better. I've had problems with these guys. So I decided to rip it out and replace it with my little board. And if you don't know what the little board is, because you've just come across my channel, haven't come across these before, I recently designed a little project board, which is to replace that shape, that format of selenium rectifier. And all it's got is 4 silicon diodes. I've used 1N4007s, AC in on the opposite ends, which is usually how the Siemens ones work. Negative comes out here, positive comes out there. Now, it's made so that I can put 3 resistors in parallel. These 3 would be in parallel, but in series with the output of the B+. The idea is to drop some voltage because the voltage drop resulting from this silicon diode rectifier, silicon bridge rectifier, is less than it would be across the selenium rectifier. So sometimes the B+ is too high. You can tame it by putting a resistor in series with the output. I've made provision for 3 resistors in parallel so you can get the right value and also distribute the power a bit. I normally use 2 watt resistors here, so I can, let's say I want, let's say I want 50 ohms. I work out 3 resistors in parallel to give me 50 ohms. I use 2 watt resistors, that means I've got a 6 watt capacity, which is fine for most applications. Now this fits in nicely here, there's a space at the back. I had to extend the positive, the B+ output wire a little bit and put heat shrink on there. Other than that, it fits quite well. And I did some cleaning on this end so I wouldn't have to come back here and spoil the new work. Now at the moment, I've just got a short across that resistor, so there's no drop of B+, because I'm still using it. I'll still be using it on the dim bulb tester. When I've got this completed, I'll check the B+ output. If it's too high, I'll start putting resistors in there. So that's done. The next stage was the filter capacitors. Now the filter capacitor here is on this end of the radio. The selenium rectifier is on the opposite end. It's right on this end of the radio, which is a little bit unusual because normally you would rectify the voltage. The output from the secondary would be rectified, goes straight into the filter cap. This time they've put it right on the opposite end, and that's not an issue. And in fact, it's good design because although you've got the rectified voltage coming from that opposite end, where it's first used is when it feeds the output transformer, which means that you rectify it and at that end, filter it at this end, and any noise on the line in between doesn't really make any difference because where you need it, you are filtering it. And you need it by the output first. There's the EL84 back here, output transformer over there. So the first B+ gets filtered with the first section of this capacitor, which is a 50-54 microfarads. So 2 50 microfarad caps and a 4 microfarad cap, all of them 350 to 385 volts. And then you send it to the output transformer. It comes through a dropping resistor, then it goes to the shield or the screen of the EL84 and it feeds the next tube and so on and so forth. So all the filtering happens and is needed at this end of the chassis, which is precisely what they've done here. I had 2 choices with this. I could either stuff it, restuff it, remove it, restuff it, or completely eliminate it and find a different place on the underside for the filter capacitors, which is what I did. Let me show you the underside. I've bypassed this completely. This thing is going to be on here just for looks and will have absolutely no function at all. Underside, please. This over here is the underside of the filter capacitor. And as you can see, it's quite busy in this area. Very busy, in fact. So removing it, putting capacitors on there would have been impossible. But the output tube is over here. So the idea is to put the filter capacitors in the proximity of the output, which is precisely what they've done with the original placement of the main filter caps. So this is where I put the capacitors. I put one over here, one over there, and one over there. So 50 microfarads. This is 450 volts, 50 microfarads, 47 microfarads really. This is a 47 microfarad at 400 volts, slightly smaller. It's still above the rating they require. but it fits nicely in here. And this is the 4 microfarad at 400 volts, which is over there for the third B+. So all this empty space under here, it's under the switch. It was completely empty with just a couple of wires going through. I decided to fit the capacitors over there. I wrapped them in black heat shrink and sort of hide them a bit. I've had criticism for this. Too bad, I like it. And this is where it's all fitting. And the negative, the ground, the common ground, which would have been the chassis of the filter can, soldered to the chassis itself, I've done here. I've actually made a very good ground over here. You can't really see it, but I've really tied the this ground leg right to the chassis. It's very, very tight. It's a good chassis ground point. So that's where the ground is now. Now, you'll see a lot of other stuff, but I'll take it one step at a time. So we've got our power supply filtering really taken care of. And what does that look like on the schematic? Let's have a look. If you look at the schematic now, you can see quite a lot has been painted in because I have done quite a bit. Let's focus on this section here, which is the power supply, the part that I'm more interested in at the moment. So there it is. We've got the mains coming in here. It goes through the fuse. The fuse is fine. We know that. The primary is all fine. That over there is the little filter cap to ground. I've put it in as well, and I've used a safety cap just to make sure that everything stays nice and secure. Then here's the secondary, and we've got it going through this section here. Now this over here should not be green because I have replaced it, right? That's more like it. It's now red. It tells me that I've replaced the selenium rectifier with a silicon one. This is the first section of the filter can, replaced as well. Then the B+ goes over here, and it goes across, and it goes across. We've got to follow this line over here, all the way across here, up to the top, up to there, where it goes into the output transformer over here, through the primary of the output, and then it goes to the anode of the output tube. That's all fine. Now here you see there's a little capacitor over here. This is to reduce high frequency oscillations. It also cuts off some of the really high frequencies. That is not a problem. That's quite usual. I've used a 630 volt cap here. Sometimes you use higher voltages, but what they've rated theirs for is 380. So I used a 630, 2.2 nanofarad instead of 2.5. That's not a problem. Then if we come down here, we come to this resistor, and this is where things started looking a little bit strange. The fact that someone's been here became obvious. You see, they had these two resistors in series in that position, and these guys are 220 ohm. These are probably 5 watt each, and that's good, but that's 440 ohms in series. What they tell us on the schematic is 1K. Now, I am not sure about this because there are a couple of other things that are slightly different from the schematic to the radio. I know this is not original, so what I decided to do is I decided to replace it with the value that is more exact. I've decided to use 2 by 2.2Ks in parallel to give me 1.1K. And if we calculate the power, this is 42 milliamp, they tell us. They tell us that 42 milliamps is passing through here at 223 volts. If I take 1K, the power is I squared R. So, you know, I squared is 42. It comes out to actually quite a bit of power. So I decided to use the two in parallel, which gives me 4 watts of dissipation in that position. There they are. So that resistor gets replaced. We've got the B+ through here, comes through here, and it meets the second filter capacitor, or rather the second section of that filter cap. That's where the one that I've put in there replaced by 447 microfarads at 400 volts. That's over there. Then that goes over here, and it goes that way. Forget about that for now. It goes through a 2K resistor, which is in perfect condition. The value of these resistors is held out very, very well. Through the 4 microfarad, which filters it further. I call that first one B+. I call the second one B2+, and this is B3+ for me. So that's just a 4 microfarad. I've actually used 10 microfarad. It just makes it a bit better. That comes up here, goes to the screen of the EL84, and it also is the anode voltage source for the triode of the preamp tube, the ABC80. because it goes over here through a 200k resistor, which is really close in value. These things haven't changed. And then it goes through here and to the anode. So all that is fine. All that has been checked. All that is fine. And what did I change later? You can probably see here there are a lot of changes, although because I've used those black Carl's caps, it's difficult to see them. All the paper caps have been replaced over here. That's the first one going backwards that you see. There's a reason why I left that alone for now. All the paper caps have been changed here, and there are actually quite a few, and some of them were actually quite difficult to get to. I found a few mistakes because, as I mentioned earlier, I'm going from the power supply then to the audio stage, and that's what I'm working on now because, as far as I'm concerned, the power supply has sort of been done, by replacing the selenium rectifier and replacing the filter capacitors. So now I'm interested in the audio stage. And if we look at the schematic, it becomes quite obvious why. This B plus is feeding the output tube, which is over here, and a screen as well. And then we've got, this thing is cathode biased. This resistor is fine. I replaced this with a 47 microfarad. This is the cathode bypass capacitor. Not an issue, quite normal. And then I started finding a few discrepancies. And here's the first one. Now, normally, this is a grid stopper for the output tube. Normally, this resistor is a 1K resistor. It can be up to 10K, not a problem. Some would say that for an EL84, the optimum is just around 10K. Some would say it has to be a little bit higher, but I've never seen one as high as 100K. And that's the value that I found on here. 100K resistor, and it is indeed a 100K resistor. There's nothing wrong with the value. Although difficult to see, I believe this is it here. It looks original. It's the same type of resistor. The solder was old. It's been there since day dot. This thing has not been replaced, I am sure. And yet they used a 100K resistor. The other thing is the one that goes to ground over the back there, as we see from the schematic, was supposed to be a 1 meg. They've used 800K. So I decided to leave the originals in there and see what happens. Why would this make a difference? Well, it would make a difference because as far as this being 800K as opposed to 1 meg, this means the voltage that's generated over here, it's going to be generated across these two resistors. That means that this would be grabbing a smaller proportion of it. Normally it would grab, 1/12, no, 10/12 rather, 10/12. Now it's grabbing 8/9, if that makes any sense. Resistor divider, as far as the audio signal is concerned. So the input level, the level of the signal from this preamp getting into the tube, getting into this point over here, would be slightly lower than if this was 1 meg. That's not an issue. It really isn't. This being that high, it could be to reduce oscillations. This has three functions, really. It stops oscillations because it creates a low-pass filter. If you imagine a resistor and a capacitor to ground, creates a low-pass filter, so it cuts off high frequencies. And where's the capacitor to ground? Well, it's actually the grid to cathode capacitance, which is not that high, but it's significant. The higher you make this resistor, the lower the cutoff point will be in the audio range. Mind you, with 100K, it's still going to be way beyond what you need, but that could be an issue. The other reason is to stop blocking distortion. So this thing would start having a voltage drop if the current starts, if the voltage is too high and this thing starts wanting to see positive voltage. You don't want that. So this stops blocking distortion. There are other reasons. It could simply be a mistake. This thing could have been put in by mistake from the factory, and I'm theorizing all about it for no apparent reason. So that stays in there for now. We'll see what the result is at the end. And then we go back. This is the capacitor that links the audio from the output of the preamp stage over here through the capacitor to the grid of the output tube, which is really what it's supposed to do. There is this capacitor here goes to the treble pot. So this is going to bleed off high frequencies, but this is the problem. The treble pot's on the radio. However, this goes off somewhere to the outside, to the speaker section, to that connector that I showed you. This will go off to some of those switches, preset switches that we have in the front, which means that at this stage, I can't really test that. I can just test the continuity. It goes to pin 9, not a problem. What else? And then, of course, we get to the preamp stage. Now, this tube is dual function. This is the EABC80 triode. This is the EABC80 triple diode. So we'll forget about this. This is for the detection. We'll worry about this in the next stage. Nice and convenient. It's sitting over here. It's very close to the output tube. And also the last 3 pins are the ones that are the triode. So it all fits nicely. And that stage there, the top section, is for the radio, for the diodes. So if we look back at the schematic, we have 20 meg to ground from the grid. This is a grid leak bias, so we don't have cathode bias. The cathode is grounded. This very, very high resistor makes sure that all the electrons that get knocked off here do flow through that. And it's not many electrons, okay, but small charge, lots of resistance gives you some voltage, which means that this bias is quite well. And the signal coming into the grid, which is then amplified by the triode and shot off through the anode, comes from here, through this capacitor, okay? And where does this capacitor get its signal from? Well, it gets it from this holy mess over here. And it's actually quite simple. All this is a volume control. It gets it from the wiper of the volume control, okay? And the volume control wiper should be, alternating between ground, between 0 volts, 0% of the signal, and 100%. So let's look at the ground. That thing there is just a shield on that wire that's grounded. But this isn't really ground. This is the problem. This isn't really ground. This has got a 100 ohm resistor over here to ground, which lifts it a bit and gives us a point from which you can play with negative feedback to get tonal effects on it. And this is what this does. This thing over here comes from your speaker, comes from the speaker output, and it goes through switching. And this would be one or two of the presets, whether you use orchestra, solo, or voice. I've gone through this kind of function on so many radios in the past. If you're really interested in looking at the detail, just go and find a few other series. I'm sure I'll bore you to death. But these resistors, capacitors here, just create a tonal shaping for the feedback to this signal that's being prepared to be sent to the audio output. And these capacitors were all changed. They were all in pretty rough shape physically, electronically. Electrically, I'm not sure, because these don't really see high voltages. They are paper caps, but they don't really see high voltages. So sometimes you can get away with not even replacing them. I prefer to replace them. And then we get to the volume pot itself. And this volume pot has got the famous pseudo loudness effect. The signal comes in at the top of the volume pot as per usual, and it comes from here. And there's a DC blocking capacitor, 10 nanofarad, also replaced, and it comes from the switching. Now the switching, the way this works is you can either have audio coming from the pickup, the phono, which is TA, or you can have it from TB, which requires you to connect phono and farad antenna switch together. And ultimately, it can come from the radio. And the radio would be FM or AM. So radio, tape, or phono. And then, of course, all of that, whatever you select, can come down to the tape output to be recorded as well, because this also has an output. So don't worry about all this. This is all being checked. It's all working. The audio comes in here, right? Top of the volume pot. Now, wiper goes to the preamp. The bottom goes to here, and there's all the tonal shaping over there. But there's also some more rubbish over here, and that is these resistor capacitor networks. This is for a pseudo loudness effect, which means that as you drop the volume, the tone changes slightly because you've got taps coming off the volume control to different resistor capacitor networks, including the bass control over here, which is also fed to the negative, to the output. So this is really it's not complex. As I said, I've done some explanations of this before. Please don't ask me which videos. I get incredibly bored watching my own videos again to try and help people. If you want to suffer, go and look at them. But I've explained all this before, how the pseudo loudness works and how these pots work. And then there's also the tone shaping that you can select and which speakers it goes to. This has all been checked. Everything's been replaced. And now we have the radio ready to test. Strictly speaking, that's not true. We actually have the amplifier ready to test. So I'm going to set this to pickup input. I'm going to feed a signal to the pickup input at the back from the signal generator, 600 hertz, 50 millivolts or so. Volume is on max, and I'm going to put one light bulb only, the 40 watt bulb. All these are off. And yep, it's glowing, but it's gone dim, which is fine. It should actually light up a bit more again. Do I hear anything? I've got it to the workshop speaker. That was the cat. See if we get some action now. I'm getting absolutely nothing. What am I doing wrong here? Something is wrong. Let me try this with the other dummy speaker. All I've got is some hum coming out of there. This is rather strange. Let's touch that. Oh. My EABC80 wasn't fitted properly in the socket. Still not getting anything. The only two tubes involved are the EL84, which is well seated. Let's see about this guy. This is really dirty. I'm going to clean that socket and try again. All right, I've got that on the scope now. Let's see. This is still dirty, the pot. Okay. Let's see if this is triggering properly. Yes, channel 3, no problem. All right, that's looking good. Let me put it on dummy load so we don't have to hear it. And I'm going to increase the volume, see where it clips. That's now on maximum volume, but it's only, I think, 50 millivolts coming in. And we're getting 600 hertz, 6.6 volts peak to peak. Let me put it on RMS, it's better. So we've got 2.25 volts RMS. Okay, let me increase the amplitude of the input signal. In fact, yeah, I can do it like that. 100, 110, 150. I'm at 160, 150, 160. Let me put it at, say, 300 millivolts. And that's going to clip, so I bring the volume down. And what have we got before it clips? About there. 3.4 volts, 3.3 volts. Okay. And then, of course, it starts clipping top and bottom. You see, I'm interested in seeing what happens because of that huge grid stopper resistor, the 100K. I'm not sure why they put it so high, but hey, it looks great. Great sine wave. Fully controllable. And of course, if I put the volume down, put this on speaker, you can hear it. But the tone controls have no effect because these are going out to the external circuitry that allows you to preset those tonal characteristics, you know, instrument, rather, what is it? Orchestra, speech, and solo. But it seems our amplifier is working, which is great. And it's actually sounding pretty good. I need to do a couple of things. I need to definitely clean the pot because it is scratching, especially at low volumes. When I get the tone controls connected, when I get the external section connected, I could check the tone controls, but I'm sure they'll work well. But yeah, I even went so far when I was having my issue with the audio, I actually replaced the EABC80, and what I want to do now is take the old one and put it back because I'm not going to use a new one unless I have to. So this is the original EABC80. The pins have also been cleaned, and I can put it on again. And yep, it's working, but is it getting the same amplitude? Let me put it on dummy load again. 3.23. Yeah, it's the same. So that EABC80 is good. One less tube to replace. I'm happy so far. And that is where I'm going to leave you for today. The next stage will be working on the radio, making sure that that works, both the AM and FM. I'm not even sure that it's going to receive anything at this stage. There are capacitors to replace on there, which is what I'll be working on next. But in the meantime, I've got the power supply and the audio section satisfactorily restored, I hope. It's sounding okay so far. And that's it for now. So I hope you've enjoyed that. And if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Once again, thanks for watching. Bye for now and stay safe.